Seamless Rail Transfer Operator SRTO project. Laem Chabang Port is one of Thailand's main deep-sea ports, which is one of the highest container transfer rates in the world, and with continuous growth rate, causing traffic congestion around Laem Chabang and its neighborhood. However, rail transfer of cargo at present remains in a minimum volume compared to road transport, which is of high cost and causing great social burden. As a consequence, Thailand bears top logistic cost in comparison with neighbor countries or significant trade rivals. The government has therefore adopted the policy to push operators towards using more rail transport use. But this could not be realized at present, as PAT is currently not ready to provide services to loading and unloading containers onto and off the rail as a single operator. For this reason, PAT has formulated the project to utilize the backport area or Seamless Rail Transfer Operator SRTO project. Using Area 4 between Wharf B and Wharf C of about 600 rai or 2.5 square kilometers as a transfer area or rail yard. The project starts with the construction of all necessary infrastructure and necessary facilities. These include the implementing of a double-track railway to connect with the line from Laem Chabang Railway Station into with the project for a distance of 4.4 kilometers, with 6-track stabling yard of 1.5 kilometers in length, enabling the stabling of 2 trains on each rail, and capable of accommodating 12 trains at the same time. Installation of equipment to loading and transfer containers on rail is carried out with rail-mounted gantry crane (RMG) as the main equipment in arranging the containers in the container yard. The project operates over the 6 rai of land at the same time. The objective is the achievement of transferring cargo in each train within an hour and achieving the expecting capacity target to accommodate containers on track up to 2 million TEU per year. SRTO project will be the beginning of enhancing potentials and capability in services of Laem Chabang Port to maximize benefits both in developing domestic logistics network, improving competitiveness, and supporting government policy in developing the country's logistics system as a whole. The project consists of the following main works: 4 project gates, 6 tracks of stabling yard, trains entering and exiting the loading and unloading container area through the 2 main railroads in the middle and under the rail, mounted gantry crane, RMG. The RMG serve as the main equipment and situated over and across the tracks. In addition to rail transportation, freight containers can access the area by the tractor trailers driving on the asphaltic concrete pavement under the RMG. Container yard for the storing of containers in series with 1-lane driveway, using rubber-tired gantry crane in transferring cargo containers onto or off by the tractor trailers. Building works consists of a 5-story office building, a canteen, and amenities, a workshop, a pump house for the firefighting system, and a power substation. Road system. The designer of the roads in the project designed the road as one-way traffic driveways to enhance transport efficiency and increase traffic flows within the port. This would accommodate fast-growing services in the future. For the Seamless Rail Transfer Operator SRTO project, Laem Chabang, the Port Authority of Thailand, PAT, has contracted ITD WH Consortium The consortium is the result of cooperation between Italian Thai Development Public Company Limited and Henan Weihua Heavy Machinery Company Limited. The former is responsible for the construction of basic infrastructure with necessary facilities, while the latter would manufacture and install the equipment in loading and unloading containers onto and from the trains. The contract for the construction of container transferring by rail center signed on 21st April 2016, with the construction work starting on 22nd April 2016. The completion date was 23rd October 2017 for the contract duration of 550 days or 18 months. With the contract price of 1,926 million Thai baht. The project can be presented in 8 essential topics according to the work details as follows. 1. General work valued 16,684,024 Thai baht. 2. Clearing and relocating of existing utilities valued 8,760,750 Thai baht. 3. Construction of container rail transferring center valued 601,708,896 Thai baht. 4. Buildings valued 56,148,954 Thai baht. 5. Facilities valued 36,222,206 Thai baht. 6. Utilities valued 347,902,723 Thai baht. 7. Contracted construction of RMG valued 586,302,000 Thai baht. 8. Contracted construction of RTG valued 102,336,000 Thai baht. Total value of construction works of the entire project valued 1,926 million Thai baht. In the presentation, construction works for the SRTO project are in the following details. 1. Clearing and relocating of existing utilities. For the construction of container transport by rail center, Laem Chabang Port, removal and relocating of existing utility works consists of clearing and relocating of existing rail tracks, clearing of existing roads, clearing of concrete storm drainage ditch, and clearing and landfilling of earth ditch to a level of the yard. 2. Construction of buildings, facilities, and utilities. 2.1. Building construction with the following main buildings in the project. 5-story office building, workshop building, canteen and amenities, entrance gates and checking posts, 4 locations. 2.2. Construction of facilities such as substation number 1 and number 2, water pump station for firefighting use, gas station, machine washing yard, parking area. 2.3. Construction of utilities with the following details: road system and landscaping, drainage system, power system and lighting within the project, water supply system, wastewater treatment system and machinery. 3. Construction of base and rail for the rail-mounted gantry crane RMG. 4. Construction of sleepers for container yards. construction of track work and track welding. Six, installation of signaling and traffic control systems. Seven, transporting, assemblage, and installation of container haulage equipment. For example, rail-mounted gantry crane (RMG), rubber-tired gantry crane (RTG), Eight, quality assurance, safety, and environment. The traffic system in the project requires an accurate and precise to conform to fast transferring services. Moreover, the project also pays attention to safety and environmental quality at the same time, with the operation to monitor environmental quality, as well as regularly checking on every step of activity during the construction, to complete the project following the drawings and specifications of the contract. Before construction work is starting, survey the project area thoroughly. The purpose of survey is to locate the positions of the objects or obstruction that must be relocated or cleared out from the construction area, such as lighting posts, fences, walls, and drainage ditch, etc., to enable the preparation of the construction area could progress as planned. After that, the contractor would clear the space following the designed project layout, clearing and relocating of existing utilities. For the construction of Freight Container Transferring Center, Laem Chabang Port, this work comprises of the following: 1. Clearing of existing railway tracks. 2. Clearing of existing roads. 3. Clearing of the concrete drainage ditch. 4. Clearing and landfilling of earth ditch to the level of the yard area. The survey team would gather the existing ground level data first. After that, the clearing and relocation works would be carried out coincidentally with the leveling work consisting of removing the current utility system, trees, and their roots, as well as topsoil. After completing these activities, fill the land by external soil to the required elevation. The filling work is performed in a layer of 30 cm thickness and then compacts layer by layer to the designed height. Following the leveling work, additional compaction and soil density test will be carried out to ascertain if the density of the filling work is meeting the requirements of the standards. The level shall be remeasured to conform to the construction plan. Construction of buildings, facilities, and utilities. Two, construction of buildings, facilities, and utilities. 2.1. Construction of buildings comprising a 5-story office building, workshop building, canteen and amenities, entrance gates and checking posts at 4 locations. Steps in building construction divide into the following works. 1. Clearing and leveling work. Prepare the work area for piles driving. The survey team would perform the setting out of the work area to mark the grid lines of the building both in vertical and horizontal directions, as well as a benchmark of the elevation. After this operation, the contractor would level the surface with a motor grader and recompact the subgrade with a compactor. Then the area is ready for pile driving operation. 2. Pile driving work. The survey team would locate the positions of every pipe on the site. The designer uses pre-stressed precast concrete spun piles of 60 centimeter in diameter with 12 meter long for the 5-story building. The pile capacity is 50 metric tons. The piles for workshop, canteen, entrance gates and cargo checking points, power substation, fire pump, and gas pump are the pre-stressed precast concrete square pile of 35 by 35 centimeters in size, with a load capacity of 25 metric tons each. Use pre-stressed precast concrete square piles of 25 centimeter by 25 centimeter for car park building. The pile capacity is 5 metric tons. After the survey crew has located the positions of each pile in any particular building area, the pile driving crew would use pile driving rigs with the required hammer weight to perform the work at the designated locations. 3. Structural work. The structural work of each building consists of the following elements. Foundation work. The foundation is the part which the function to carry the weight of a structure. Buildings in the project are of deep foundation type, which transfer building weight to ground through piling system. Foundation work starts with the pile head cutoff work, which is the process to cut out the excessive pile length above the pile cut-off level. After completion of pile head cutting, the bottom of the footing area is leveled with sand working mat, and lean concrete is poured to facilitate the construction of the footing. This is followed by marking the positions of the individual pile in the foundation to check the eccentricity of piles. After fixing the steel reinforcement bar cage of the footing and starter bars for the column and formwork, the engineer shall inspect the work before pouring the concrete. Ground beam work or ground floor beams. The structure of the building is a reinforced concrete structure to bear the load from the first floor slab. The construction work will be commenced by leveling and compaction of the bottom of the beam area and pouring the lean concrete. Then the survey crew will locate the position of a beam. Then steel reinforcement bars are fixed in place and followed by the installation of formwork. After these works are completed, the engineer shall also inspect the work before pouring concrete. First floor work. As the first floor is the lowest story of the building, therefore we can use the filled soil with sand topping and lean concrete as the bed of the floor slabs. Before lean concrete is poured, verify the floor level against the drawings by site engineers for correctness. After placing the lean concrete and reinforcing steel bars, concrete is poured using a concrete pump. During concreting, the concrete will be compacted by a vibrator to ensure all the concrete ingredients are well compacted and without any cavity. The final step of the work is the finishing of the concrete surface to maintain the design thickness and design elevation. Column work for the first floor and install of reinforcement bars and formwork following the drawings. Inspect the work for correctness and pour concrete up to the bottom of the upper floor's beam. Beam work for upper floor and erection of steel scaffoldings for installation of the bottom formworks the beam. Then installing reinforcement bars and side forms. Inspect the work and then placing the concrete by using a concrete pump and compact the concrete by vibrator. Slab work for the upper floor by erection of steel scaffoldings and installation of bottom form for the slab. The survey crew will check the elevation of the bottom of the slab and erect the benchmark for the thickness of the slab. This is followed by the installation of steel reinforcement bars and side forms. After passing the inspection by the engineer, the concrete is placed by using a concrete pump and compact by vibrator. Before the concrete surface is hardening, the surface shall be leveled and finished by a mason, with checking the elevation of the surface and thickness of the slab from time to time to avoid any mistake. 4. Installation steel roof structure work. The top of the building is made of steel roof truss and purlins. The steel structure elements will be cut, fabricated in the temporary workshop. Then, they are transported to the working area for assembly and lifted and installed on the top of the columns using the crane as per the design drawings. 5. Roofing work. The metal sheets are selected as roofing material for the building. The roof sheets are lifted and installed on the roof structure as per the manufacturer handbook. 6. Architectural work. After the building structure is completed, the next activities are architectural works, such as masonry and plastering. Doors and windows. Ceiling, tiling, and painting. Architectural works are construction works for function and appearance purposes, which must be stable, strong, and serve the purpose as they are intended and safety in operation. 7. Procurement and installation of electrical systems for the building. The works include the following: power supply system with the installation of related parts, comprising main electric distribution board, electric lamps, switches, sockets, circuit breakers for air conditioning, elevator and pumping systems, including lighting rod and grounding system. Communication system comprising telephone and computer system, fire alarm system, closed circuit television CCTV, public address system, Procurement and installation of sanitation systems in building. The work include the following: cold water system with systems and related equipment as follows. Transfer pump, booster pump, 2,000-liter water tank, water distribution system pipe, sewage and drainage system comprising sewage water drain pipe, wastewater drain pipe, vent pipe. Storm drain system comprising downspout, drain pipe around the building. 9. Procurement and installation of mechanical systems in buildings. The works include the following: air conditioning and air exhaust system, comprising the following: split-type air conditioner, exhaust fan, fire protection system, with the installation of the following related components: external fire water receptor, internal fire hose cabinet, and fire extinguisher, etc. Elevator system. The elevator is explicitly installed in a 5-story office building, according to the regulation which specifying that any building of 5 floors and more elevator is required. 2.2. Construction of utility buildings. The required facilities include substations 1 and 2, fire pump, gas pump, machine washing yard, and car park. The steps in the construction of various project facilities are the same as in building construction work, with some additional details for different types of facilities as follows. Substations 1 and 2. Extra power systems to be procured and installed are ring main units, transformer, generator, fire pump station. The particular fire protection systems to be procured and installed are fire pump, jockey pump, fire pump and jockey pump control cabinet, fire water distribution system to other buildings. Gas station. The particular gas distribution system and gas storage tank are procured and installed as follows: 15,000-liter underground diesel tank, petrol pump, gas pipeline, gas pump dispenser. 2.3. Construction of public utilities. The works required by the contract requirements comprises the following: road system and landscaping, power system, drainage system, water supply system, wastewater treatment system, various mechanical systems. Individual public utilities work consists of the following details. Road system, container yard driving lane, the road in the office area, landscaping. After the compaction of the road subgrade has been completed, the following works must be performed. Firstly, the sub-base layer work will be executed by filling with the required selected material or laterite to the required thickness in compliance with the contract design drawings. Then it is compacted by heavy compaction machinery to the required elevation. This is followed by performing the field soil density test to determine the degree of compaction. Secondly, the base course layer will be carried out. The base course material or crushed stone will be spread over the sub-base layer in layers, not more than the allowable thickness. It is followed by compaction of heavy compaction machinery and leveling to the required elevation and gradient by motor grader over the entire road area. After passing the soil density test, the surface is sprayed by water to appropriate moisture content, and the surface is cleaned. The prime coat is sprayed over the entire surface and let the prime coat to be cured by 2 days to increase adhesion of the prime coat and the crushed stone of the base course. Thirdly, after 2 days curing, the paving of the road surface will be performed using asphaltic concrete road pavement materials. The paving will be completed in 2 layers of 5 cm thickness for each layer. Each layer of the asphaltic concrete pavement will be compacted by steel wheel roller. Before paving the second asphaltic layer, tack coat will be sprayed over the surface of the paved asphaltic concrete surface. The process of the second layer of asphaltic concrete pavement work is the same as the first layer work. After testing the density of the asphaltic concrete material by drilling the pavement material and the result meets the contract specification requirement, the total thickness of the road pavement is not less than 10 centimeters. The road pavement work is completed. Finally, the traffic line and traffic directions symbols are painted on the road surface. The drainage system. The work begins with the dispatching of the survey team to provide the locations, level for excavation of the manholes, as well as providing the alignment of the drainage pipe on site. The surveyor will give the distance for offset from the center lines of the manholes. After survey work, sheet piles are driven around the offset perimeters of the manholes and both sides of the drainage ditches to prevent the instability of excavated pits. The excavation of the manholes and drainage pipeline will be performed according to the elevation and alignment of the drainage pipes provided by the surveyor. After water is pumped out of the excavation ditch, lean concrete is placed at the elevation of the bottom of the drainage pipes. This is followed by the layering of concrete drainage pipes into the ditch with the alignment provided by the survey team. After all the concrete drainage pipes have been laid in place, adjustment of the alignment will be performed by backhoe before grouting the joints between each concrete pipe with mortar. Manhole pits are excavated in the position and level as designed in the contract construction drawings near the outer perimeter of the manholes. The precast concrete manholes are lower in the pits according to the locations and elevation of the drawings. Grouting joints between pipes and manholes before backfilling with the excavated soil in layers of 30 centimeter thickness. Compaction and soil density test will be carried out. The next step is to construct the upper portion of the manholes in place by installing the reinforcement bar cages and formwork around the wall of the top edges of the lower part of the precast concrete manholes, with the embedment of all steps of the steel ladders. Before concrete is placed for the upper of the manhole, the steel seating for the manhole cover shall be installed, as well as preparing the reinforcing steel bar of the manhole cover, using the factory-made manhole cover steel frame. Finally, concrete is cast for the wall of the upper portion of the manholes and manhole covers. The power system. The power system of the project consists of the power system and lighting works. Power supply and lighting system in the project have the following operational details. The placing of underground power cables for electrical system in the project. The cables for power supply will be used in the underground for no exposure, safety, and enhance the efficiency of the power distribution system. As for the undergrounding of power cables, apart from the electrical system, wire cables for the communication and the CCTV system are also laid for stability and enhance capacity and reliability. The power system in the project can be classified according to functions as high voltage electricity, 24 kilovolts from PAT. Low voltage electricity, 220 volts distributed to the building zone. High voltage electricity, 11 kilovolts and 6 kilovolts distributed to RTG and RMG. Low voltage electricity, 380 volts, distributed to electric light poles at the container yard. Street lights around the buildings. Installing of high-mast lighting system. High-mast lighting will be used in the stabling yard and the container yard area. This can be provided into 3 scopes of work. One, laying of electric cables. 2. Post foundation work. There are 4 piles in any footing. Then install reinforcement bar cages and set up formwork before pouring lean concrete. This is followed by the embedding of bolts for installation of the electrical poles. 3. Installation of the electric poles. The power poles are made to order from the factory and brought to the workshop for installation by using a crane. The production is fast and straightforward, with 8 to 10 poles per day. After installation work is finished, test the lighting systems by personnel in accordance to the specifications. Water supply system with the following details. Pipe laying for external distribution system HDPE pipe will be used in this distribution system. Pipes were located at the following points. Water distribution system around building zone. Water distribution system for buildings around checking post number 1. Water distribution system for buildings around checking post number 2 to checking post number 3. Wastewater treatment system, which is the sewage collection system comprising digging and laying of collection sewage pipes, relocation and installation of the central sewage system to connect with existing sewage collection system, as well as the installation of wastewater treatment tank for the project. Mechanical work as external fire protection for buildings with the following operations: digging and laying of the pipeline for fire protection system and fire hydrants pipeline are being placed for fire protection system around the construction area. This consists of the following: piping for the fire protection around the project, piping for the prevention of fire into the buildings. In addition to the piping system, the fire protection system will be equipped with accessories around the area to serve the purposes intended as follows. Fire hydrants comprise 1. Hydrant, 2. Underground hydrant, 3. Fire receptor, 4. Fire cabinet. Construction of base structure and rail for rail-mounted gantry crane. Construction of base structure and rail for rail-mounted gantry crane comprises driving of spun pile, diameter 60 centimeters. Construction of base structure for RMG. Installation of fasteners for RMG. 1. Piling work for precast concrete spun pile, diameter 60 centimeters. The survey team marked the positions for each pile to be driven with high accuracy. The location marks for piling will be checked every day to ensure that no deviation of the marks due to whatever reason it occurred. The piles are driven by mobile pile driving equipment with vibrio hammer of drop hammer weight 7 metric tons with 60 centimeter dropping distance. During the pile driving process, piling work foreman shall control the plummet of the pile to be vertical in all direction, as well as the position of the pile not to be relocated. When a pile is driven with advancing penetration into the ground, blown count is recorded for every 30 centimeter penetration. After the pile is driven with the tip reaching the designed elevation, the last 10 blows driven of that pile is collected and verified in the field to ascertain that the pile is driven to the depth capable of sustaining the design load. After a pile is driven in place, the hollow hole of the pile must be closed, as well as erecting a red-white flag for warning of the public and the working personnel. 2. Construction of base structure for RMG. After all the piles are driven in place according to the design drawings, the ground around the piles will be excavated using a backhoe. The survey team then marks the level for pile head cutting off. Workers will cut all the piles heads to a designated elevation. Before other construction work is commenced, the survey team will collect the as-driven pile locations of each pile for comparing with the allowable as-driven pile deviation tolerance value. In case that the as-driven pile location deviates more than the allowable tolerance, then modification of the structure is required. Otherwise, the area is compacted for using as the bottom formwork of the base of the RMG by a layer of sand working mat under the layer of the lean concrete. However, before placing lean concrete, the pile heads shall be inserted with a starter bar cage with sufficient encouraged length in a pile and the base of RMG, then filled with structural concrete of the same class with the base. During performing the above construction work at the site, steel bars are bent in the rebar yard and then transported to the site for fixing at the base of RMG supporting structure. Prepared steel bars are tied and bent as RMG support structure to make for the concrete casting process for the RMG support base. After that, formwork for the sides of the base structure is erected and ready for casting concrete. Due to the height of the RMG base structure, concrete placing has to be divided into 3 layers to ensure that the lean concrete slab could support the load of the concrete for the first layer. After the first layer of concrete is poured, use soil to fill both sides of the base structure for ease of steel fixing work and erection of formwork. The design of the concrete formwork for the second layer requires the installation of jigs. These jigs are fastening devices to support the hanging and securing of the J-bolts in place at the correct position before the erection of the formwork. After the erection of formwork, then concrete is placed. After concrete pouring for the second layer, the skilled workers would assemble structural steel angles of 50 by 50 by 6 mm in size, as well as fabrication of formwork and erection in place before casting concrete. Finally, the third layer concrete is placed. 3. Installation of rail fastening system and A100 rail track. The work is constructed in the following sequences. 3.1. Install the sole plates and adjust the level in place to the position as specified in the drawings. 3.2. Inject non-shrink grout under the sole plates. This will increase better bonding between the sole plate and the base structure of RMG. 3.3. Install A100 steel rail by transporting and distributing the rail from the stockpile and arrange them over the sole plates. Finally, support the rail with sleepers or steel rail ready for rail welding. 3.4. Realign the steel rails with alignment frame. After all the steel rails are placed in the right positions, make preparation work for rail welding by the aluminothermic method. Smooth the welded surface of the welded joints with a grinding tool. After the rails are welded, check the integrity of the welded joints by ultrasonic test to ensure that no defect has occurred inside the welded joints. 3.5. Install rail fasteners by using torque switcher to fix the nut firmly with the anchor bolts. Check the level and alignment of tracks for the last time. Erect wheel stops at the end of the steel rails and at the supporting points for the device to lock the lower structure of the RMG to prevent overturning of the RMG during a storm. Construction of sleepers for container yard. There are 1,956 pieces of concrete sleepers to be constructed in the container yard areas of the project. The function of the concrete sleepers is to support the containers, prevent them to contact with the ground directly or soaking in water after rainfall, and preventing damage to the containers, as well as acting as the foundation to distribute the weight of the containers while stacking in several layers height. Construction of sleepers for container yard can be divided into the following steps. 1. Reclaiming earth fill. Fill the area for the construction of concrete sleepers with soil to the levels specified by the plan. Then compact the filled materials by compaction machinery to the density required by the specifications. Check the degree of density of the subbase at any location with the field density test method. After that, perform setting out by the survey team to locate the positions for the construction of concrete sleepers. 2. Excavation works. Excavate the filled area to the elevation given by the survey team. The ditch for construction of sleepers is 2.4 meters wide, 9.15 meters long, and 0.4 meters deep. Fill new laterite over the existing laterite subbase and follow by compacting to 20 cm thick. Fill crushed stone at base course by spreading them over the laterite layer. Then compact the crushed stone layer thoroughly to 20 cm thickness and check with density test. Fixing of reinforcing steel bars and erection of formwork. The rebar fixing work is divided for 2 sleepers. The first one is 1.9 meters wide and 9.05 meters long, while the second one is 1.9 meters wide and 6.3 meters long. The distance between the two is 1.1 meters apart. Then set up the steel formwork panels of the size 2 meters wide by 50 centimeters height. After the rebar, workers have completed the rebar fixing work and the steel formworks are erected, the survey team will verify the correct position of the works. Before formwork is set up, the formwork workers will apply form oil on the inner surface of the steel formwork to facilitate the removal of formwork after casting concrete. 7. Concrete placing work. Placing concrete after the completion of rebar fixing and formwork erection works. The strength of concrete shall be 240 KSC. During concretion, the concrete workers will use internal concrete vibrators to compact the concrete in the internal sides of the forms. The purpose of this process is to allow all the concrete ingredients to thoroughly fill all the spaces in the forms without any honeycomb, trap bubbles, or segregation of concrete. Chamfer all top corners of the sleepers. This is achieved by installing a form material of triangle shape to the sides of the inner formwork at the required level before casting concrete. During concretion, the mason workers will level the top surface of the concrete with a steel trowel to obtain a steel trowel finish surface. After all concrete is in place, the concrete will be cured by a spraying of a curing compound over the exposed surface of the hardened concrete to prevent immature evaporation of the water in the hardened concrete before it has fully hydrated with the cement and gaining the required strength. The curing process takes at least 7 days. Then the formwork can be removed. Backfilling work. Fill the sides of the concrete sleepers by dividing the work into 3 layers, using different materials for each layer as follows. 1. Laterite layer. Fill this layer with laterite material to 20 centimeters thickness. Then, compact by roller and verify the degree of compaction by soil density test. 2. Crushed stone layer. Fill the laterite surface with crushed stone for 15 centimeter thickness. Then, compact by roller and verifying the degree of compaction with soil density test. 3. Asphaltic concrete layer. Asphaltic concrete is laid at 5 centimeter thick. Then compact with a steel wheel roller to an even surface. Before completing the working process, the asphaltic concrete in place is tested by density method under the procedure and method of the Standard of Asphaltic Concrete published by the Highways Department. Railway trackwork construction. Trackwork system is vital for freight trains or rail transportation system. The construction of trackwork can be divided into 4 main elements as follows. One. Installing of turnouts. Two. Relocation of turnouts and old railway tracks from old stabling yard section B and C. 3. Install new railroad on main line, double tracks, from Laem Chabang train station to the cargo area of SRTO project. Four. Installing of level crossings. One. Installing of turnouts. Install turnouts on the rail tracks to control the change in the direction of the trains. This would make trains diverting from the original track as required. The installation of turnout work begins after completion of the subgrade, sub-ballast layer respectively. The survey team is dispatched to the construction area to set all the reference pegs at 20-meter intervals for straight track section and 10-meter intervals for curved track section. The team will indicate the positions for cutting the existing rails to install the turnouts. After pegs are located, the assembled turnouts which have passing inspection are transported from the factory to the stabling yard. For ease of transportation and installation, the turnouts are separated into 2 panels. Both panels are transported by trailers from the factory to the entrance of the railway construction zone, waiting for permission to start the installation. After obtaining the permission from the State Railway of Thailand, start the cutting of the existing rail tracks at the designed positions. After cutting the existing rail tracks, Remove the cut materials in the original rail panels, then take out from the rail track construction zone to facilitate the free flow of further construction traffic and for safety purposes in the next step of work. The workers will slice out some of the old ballast to about 15 centimeter thick. Then, the roller will compact the remaining ballast. After that, turnout units are put on the compacted ballast. Turnouts are picked one by one from the trailer and put on the ballast until they are aligned according to the plan. When all parts of a turnout are placed on the ballast, they are fastened with C-clamp track fasteners. The fastened turnouts are inspected for accurate alignment before ballast is put in the cavity of the turnout and the bearers. Proceed the spreading of the second and the third layers of ballast by shoveling and spreading the ballast onto the rail tracks by a backhoe and compact it to the specified level with a steel roller. During construction, the speed-reducing warning signs and other signboards as required by the train operation procedure, as well as the signaling system are erected or installed to alert the train engineers to reduce the train speed and follow the order depicted on the signboard and signaling lighting. After locking, the existing railway turnouts as per prior approval temporary railway detour layout using a lock device and secure the device with locks and keys and hand over to SRT officials. In the next step, joint inspect the constructed railway track with SRT officials before moving all the machinery out of the area. Then recheck the railway work before official track opening for train operation. Relocation of turnouts and old railways from Old Stabling Yard, Section B and C to SRTO, Project Cargo Area. At the SRTO Freight Transfer Zone, where the rail tracks will be constructed, after compacting the sub-ballast layer, fill the track formation with ballast which is transported from the crushing plant or the temporary ballast stockpile located on-site by trucks. Limit the truck speed to lower than 20 kilometers per hour to prevent causing any damage to the sub-ballast layer. After that, spread the first ballast layer material over the sub-ballast layer and spread the ballast to cover over the entire sub-ballast surface using wheel excavators. The first ballast layer is designed for about 10 to 15 centimeter thick. When the ballast has been evenly spread, inspect the alignments and the level with the reference pegs given by the survey team. Then start the operation of clearing and relocating the existing railways in the freight transfer zones B and C. The cutting of rail tracks starts when the approval is received for further operation according to the Windows time. The working process starts with taking off the fish plates of the rails at specific positions given by the survey team, as well as clearing the old signaling system. Old track panels that have been cut are lifted by crane onto the trailers and transport to the SRTO cargo zone. Next, while the trailers are transporting the track panels into the SRTO freight cargo zone, a crane will lift the track panels onto the first ballast layer. At the same time, the workers will adjust the alignment of the rails simultaneously to the nearest design positions. When the process is finished, the trucks will transport the ballast to the stabling yard area for laying the second ballast layer. In the meantime, the workers will make a preliminary alignment of the track to the acceptable deviation tolerance, and to enable the ballast hopper wagons to run safely on the new rail track using track lifting and slewing machine. After arranging the track elevations, fasten the track with fish plates temporary to fix various parts of the track panel in place, as well as change all the damaged old wooden or concrete sleepers, and recheck the track gauge. If the gauge is not conforming to the specification, then loosen the bolts and the nuts of the fish plates for reinstallation. Then realign the track alignment using track lifting equipment to lift the rails vertically and slewing machine to adjust the horizontal elevations and alignment of the rails transversely. At the track joints, use fish plates to fix the rails temporary for the preparation of rail welding work. Rails will be welded by aluminothermic welding method. Filling the second ballast layer, the workers will use a backhoe to shovel ballast from the stockpile yard onto the ballast hopper wagons. As for storage of ballast, the stockpile should not exceed 3 meters high, and sprinkle water regularly to prevent the spreading of dust to the people in the area. Push the ballast by rail or road shovel, VAIA CAR 704 FC, to the designed formation. Simultaneously adjust the alignments and the elevations of the rails by a track lifting and slewing machine. Then retamp the ballast material with a rail or road shovel, VAIA CAR 704 FC machine, with specially installed the ballast tamping heads. Before filling the ballast of the next layer, recheck the track gauge. Spreading the third ballast layer by ballast hopper wagons. First, drive the ballast hopper wagons on the rail tracks slowly and steadily. When the wagons reach the location for spreading the ballast, the drivers will turn the steering wheel to allow the ballast to open the window of the hoppers, to allow the ballast to spread over the rail track area. Then, push the ballast to the rail tracks by ballast regulator to the required quantity and formation. After that, adjust the alignment of the railway track and the elevations of rails by the tamping machine, as well as tamping the ballast to the required density. The result of the tamping of the ballast layer by the tamping machine, by the lifting of the elevations of the rails, would achieve an entire thickness of the ballast under the track sleepers of 30 centimeters, by measure from the bottom of concrete sleepers. In the next stage, recheck the elevation of the rails and the alignment of the railway track by the survey team, simultaneously with the operation of the tamping machine, until achieving the required alignment and elevations. After all the criteria are achieved, reshape the ballast with a ballast regulator for a final touch. Three, construction of new railway tracks on main line, double tracks, from Laem Chabang station to SRTO freight transfer zone, with the following steps. Transport all the main construction materials as rails, concrete sleepers, and track fasteners to the material yard of the project. As the contractors has to import the rails and the fasteners with long lead time, therefore, the material yard for these materials is situated in the old railway area in Wharf C, at the entrance to the project area. When these materials are required for using, they have to pass the customs clearance before taking out of the yard. for concrete sleepers, which are manufactured in factory at Ampher Vihan Dang, Saratburi province, are transported to site by trucks or trains, depending on the quantities and the usage in various periods of the project. A lorry can transport about 90 to 120 concrete sleepers per trip, while a train can transport 1,200 concrete sleepers per trip. After completion of the compaction process of the sub-ballast layer, drive the pegs for reference with the following process. Drive the reference pegs by the topographic survey team at 20 meters interval for straight line and 10 meters for curved line. To display the milestones of the railway in the project and distance between the center lines of the old and new railway tracks. After that, distribute the concrete sleepers by the workers along the shoulder of the railway formation by a crane with sleepers lifting device which could lift the 8 concrete sleepers per lifting. Concrete sleeper trucks should use the lowest speed in entering track shoulders at no more than 10 kilometers per hour to prevent damaging the sub-ballast layer. In case of transportation of concrete sleepers by train, the train would run on existing main line between Laem Chabang train station and Laem Chabang port. The train would stop along the route in the construction area and lift the concrete sleepers on the shoulder with the gantry crane installed on the train. Transporting 25-meter steel rails. Transport the 25-meter steel rails by trailers mounted mobile crane to the material yard situated beside the railway track and ready for further installation. Placing the first ballast layer ballast truck. The ballast truck is linked with the ballast paver for spreading the ballast. When the vehicle is moving, ballast would flow into the ballast paver. The function of the ballast paver is in adjusting the level of ballast to the design size and thickness of about 10 to 15 centimeters. After that, inspect the alignment of the railway and the elevation of the track against the reference pegs given by the survey team. After checking the elevations of the track and the alignment are correct, lift the concrete sleepers by a crane or rubber-tired excavator with capacity of about 4 to 5 metric tons on the first ballast layer. Then adjust the spacing of the concrete sleepers' center lines to 60 centimeters. Installing rail tracks. After the alignment of the track and the center line spacing of the concrete sleepers passing the inspection, place the rubber rail pads onto the shoulders of the concrete sleepers and lift a 25-meter steel rail on the rail pads and align the track properly. Recheck the rail gauge and the elevations of the concrete sleepers. Then install the rail fasteners or spring clips using a clipper machine or hand tools clipper device. After that, recheck the track gauge, rail elevation, and alignment of the railway. In case the results are not correct, release the bolts and nuts of the rail fasteners and reinstall the track. After that, connect the 25-meter steel rails temporarily by fish plates or C-clamps, ready for welding to a long welded rail of 100 to 200 meter long. Then weld all the joints of the steel rails into a long welded rail, with chemical welding or the aluminothermic welding method. Following the welding, verify the qualities of the welding joints by ultrasonic test. Place the second ballast layer and the third ballast layer by the ballast hopper wagon loaded with ballast. The workers will use excavator or backhoe to shovel the ballast from stockpile onto the trail ballast hopper wagons, which moves along the track. When the train, which moves slowly and steadily along the track, reaches the point for placing, open the lower window of the wagons to let the ballast fall onto the rail track. Then spread the ballast to the design formation with a ballast regulator. In the next step, tap the ballast on the railway track and simultaneously adjust the alignment and the elevation of the rail track by a tamping machine model 08163S, owned by Italian Tire Development Company Limited. Thereafter, drive the reference pegs along the rail track by the survey team for controlling the elevations and the alignment of the whole railway section at 20 meters and 10 meters interval for direct line and curve line, respectively. Use the reference pegs along the line for adjusting the constructed railway elevations and alignment by the tamping machine. In the placing of the first layer of ballast, adjust the elevations of the rails and the alignment of the constructed railway by a tamping machine to the required design coordinates. This machine performs the activity in adjusting the rail track by lifting the rails and tamping the ballast under the sleepers to the required density with 30 centimeter thick measures from the bottom of the sleepers downward. Vibrate and compress the ballast by a track stabilizer. The purpose is to make the ballast to be well arranged and increase the density with minimum future settlement. In this stage, verify the elevations and the alignment of the railway by the survey team simultaneously with the operation of the tamping machine to the required criteria. Then de-stress the rails and continue to final weld of the remaining rails until completion. After placing the second ballast layer, the elevations of the rails are very close to the design elevation. Finishing work at the final stage. The workers use a ballast regulator to readjust the level of the ballast until meeting the design formation. Then clean the constructed railway with air compressor placed on a trolley and pulled by a small locomotive to move along the rail track. The purpose is to eliminate the dust and unwanted materials. At the same time, the workers will replace any damaged concrete sleepers or track fasteners caused by ballast tamping operation. After this activity, install the clearance pegs, kilometer and half-kilometer markers. 4. Level crossing work. The level crossing is a part of the rail track that crosses a road at the same level. Neither an overpass nor a tunnel is provided for the safety of road traffic. As for the level crossing in the project, level crossing parts are manufactured in factories in Amper Wihan Dang, Saratburi Province, and transported by trucks to the storage area in front of the site, waiting for installation. After obtained permissions from the State Railway of Thailand, close the road from traffic and dig out the existing road pavement at the crossing using a backhoe and a front-end loader model PC200. The excavated road pavement must be of the width, length, and depth according to the construction drawings. At the same time, install the signaling work sleeve under the crossing. When removing the road pavement, compact the existing road base to the design density using a roller. Then place a sub-base material and crush stones in layers, which not exceeding 15 centimeters thick. After the above process, place the external supporting beams and spread the first ballast layer of 15 centimeter thick. Next, put the concrete sleepers and steel rails on the crossing on top of the first ballast layer. At the same time, assembly the component of the rail tracks and install track fasteners and temporary clips at the joints of steel rails. Follow this step by placing additional ballast to the required level. Then adjust the track elevations and alignments by a tamping machine or a hand tamping machine. The machinery could lift the track and tap the ballast under the sleepers to the required density by vibration and tamping the ballast. In the next step, install a track pad at the rail web, both outside and inside for protection of impact load, as well as on the external supporting beams. Then the workers will lift the crossing panels and put them in panels and panels between the rails to complete the work. After installing railway crossing, level the road pavement surface in the adjacent area to be even smoothness with reinforced concrete or asphaltic concrete as specified in the construction drawings. Next, install the signaling system and weld of rail joints using aluminothermic welding method. Drainage system for the double-track railway. The project has prepared a drainage system for the area of double tracks railway by constructing bridges and box culverts. For the bridge construction work, a new bridge is built along the existing bridge of the existing railway alignments. The function of the newly built bridge is to prevent the obstruction of existing drainage ditches around the project area. In addition to the bridges, the function of the newly constructed box culverts is to facilitate the drainage of the double tracks railway entering the stabling zone. The process of construction is starting by the construction of the bridge foundation to support the bridge or bridge piers. Next, erect the precast pre-stress concrete bridge girders. For the construction of track work, the critical operation that connecting all steel rails together into a long rail capable for train to run over is the rail welding work. The welding of steel rails is done with a thermit welding process. This is based on chemical principle by using a mixture of metal oxide and aluminum or aluminothermic welding process. In the thermic welding process, special precaution is needed as there is very high temperature generated from the chemical reaction. Welders must wear a fully enclosed clothing with fitness. Inspect the safety and readiness of the welding crew regularly, as well as on the safety gears and welding tools. Cut the steel rails with care using appropriate equipment. Thermit welding or aluminothermic welding involves the following sequences and procedures. One, preparing the material for welding. Cut the steel rails and adjust the gap between the ends of the two pieces of steel rails to 2.5 centimeters apart. Next, check the levels of the top of the rails to comply with the manufacturer's specifications. 2. Assembly the mold and seal of all joints between the molds with luting sand or paste to keep the liquidized steel from seeping. 3. Assembly the crucible which contains thermic welding powder inside. The welding powder will melt when heated and weld the steel rails together. 4. Preheat the ends of the two steel rails for approximately 5 minutes to soften the upper and lower portions equally. The duration for preheating depends on the size of the steel rail to be welded. 5. Use igniter to ignite the inside of the crucible, which containing the thermic welding powder, and close the cover firmly, allowing the chemical reaction to take place in the crucible. The ignited welding powder will liquidize the steel material and flows to the underneath mold. After about 3 to 5 minutes, when the liquidized steel begins hardening, take off all the elements of the tools. Shear the excessive welded materials with a hydraulic rail shearing machine and grind the welded joints of the steel rails neatly with a rail flexible grinding machine. After completion of the welded joint grinding, check the welding joints with a straight edge ruler. Next, verify the integrity of the welded joint with ultrasonic test, UT. Railway signaling system. Railway signaling system consists of mechanical system type, lighting signal type, and computerized system. The purpose of the system is to control the railway operation. It will notify the train engineers regarding of rail traffic condition ahead. This would make them make the right decision whether to halt or slow down or control the direction of the trains. This would make the trains run with safety, fast with efficiency, especially for two trains running head-on on the same route, or to switch the track to a siding at the train station. Another purpose is to control the train operation, to be punctual, meeting the train schedules. The survey and design of the railway signaling and controlling system have to take into account of safety and topographical features, such as the degree of gradient, bends, and the track condition, as well as the size of the communities along railway lines, for the relocation and addition of new tracks. The signaling system comprises 1. Signaling arrangement plan. 2. Bonding plan. 3. Cable plan and cable route. 4. Control table. 5. Interlocking circuits. 6. Level crossing, 3 sets. Installation of railway signaling and controlling system involves the following operational details. Installation of location case control cabinet. In installing the location case, improvement must be made to the interlocking circuit to accommodate the new devices put into the system. Laying cables between relay room and location case control cabinet. The cables must be capable to accommodate the capacity of the added devices and avoiding the alignment of the newly construction tracks. Details of cables are defined in the drawings of the cable plan and cable route. Construction of manholes. As there are several underground electric wires and cables for various systems in the project, therefore, construction underground manholes is necessary for the persons responsible for various systems to use in the inspection and maintenance of various electrical systems. The construction will be conformed to the standards set by SRT. Excavation and installation of wiring conduit for the new cable lines with safety and enhancing the efficiency in data transmission. Various cable systems will also be running underground as well. The alignment of the wiring conduit will be excavated and installed in parallel to the railway line. Installing of wiring and cables for relay and external cable in the relay room. Installing of additional terminals at cable terminal rack. Install additional terminals at the points of the cable installation for additional railway devices. The details are depicted in the interlocking circuit drawings. Installation of signal gantry and line side signaling. This work consists of the following. Construction of concrete foundations for location case and new signal. Erect posts and install the signal gantry. Install signal lighting lamps. Installation of concrete bases for road barriers, type A1. The concrete bases for road barriers are required at the following 3 points. Kilometer 140 plus 679. Kilometer 141 plus 770. Kilometer 142 plus 559. Each base for road barriers consists of a control hut for SRT official in charge at the railway crossing. The control hut will be built simultaneously with the construction of the concrete base, with the following steps. The construction of control hut for SRT officials. The work starts with the fixing of the reinforcing steel bars and setting up of formwork for the beams of the hut. Next, construct the roof structure and the roofing works. Then excavate the soil and laying UTX conduit under the railway. This is followed by bricklaying, plastering the walls, wiring the tail cable to the control cabinet, and installation of location case LX cabinet. After that, install the materials and instruments for the boom barrier. This is followed by install the materials and instruments for road barriers, sodium posts, road barrier, RWS post. Then install the road barrier with trolley and barrier bumpers. Finally, install track circuit, laying track box for track circuit work, including install electrical point machine. Procurement and installation of RTG and RMG equipment to lift freight containers. Seamless Rail Transfer Operator SRTO project, Laem Chabang Ports. Is a cooperation between Italian Thai Development Public Company Limited and Henan Weihua Heavy Machinery Company Limited from China, responsible for all the construction programs of the project, as well as the acquisition and installation of equipment to handle freight containers both for rail and for road. Consists of mounted gantry crane, RMG and rubber-tired gantry crane, RTG, respectively. Rail-mounted gantry crane, RMG, will be used as the primary equipment for the arranging of freight containers in container yard area. RMG can operate over the rail tracks, 6 tracks at the same time. As for rubber-tired gantry crane, RTG, will be used as the equipment for transferring service from tractor trailers. The capacity can lift and transfer freight containers. Both kinds of equipment will be transported by ship from China via Henan Weihua Heavy Machinery Company Limited. Procurement and installation of RTG and RMG equipment. One, rail-mounted gantry crane, RMG. The structure of RMG is very big. For the convenience of transport by ship, it is necessary to separate the equipment into legs and gantry and transfer it to rail stabling yard, waiting for further assembling and installation. When all the parts of RMG equipment are transported to site, then the assembly and install operation is started with a crane lifting the gantry parts to mount on the leg components. Before starting the assembly work, the construction of the base structure and installation of rail for RMG have to be completed. Two, rubber-tired gantry crane RTG. The whole piece will be transported by ship from China to Thailand, landing at Laem Chabang Port, then transfer for installation at rail stabling yard. After all components of the equipment are assembled and installed at the designated area, the workers will connect the cable system with the power supply system for controlling the equipment. After that, an inspection will be made to ensure the accuracy and readiness of various systems of the equipment. The equipment for lifting and transferring the freight containers are the necessary equipment. Essential for enhancing the readiness and the capacity in servicing the transfer of containers by rail, as well as accommodate future increasing volume of containers transferred by rail. Control of quality, safety, and environment. Italian Thai Development Public Company Limited's motto is adhere to contract, building trust, and pay attention to quality, gives priority to every step of work. Consequently, the company pays attention to the welfare and living condition of personnel, quality control, safety concern, as well as accident prevention measures. Ultimately, this would lead to the management of environmental impacts, as well as public relations work of the project, and communication to reach an understanding with communities in the construction area, to prevent and minimize impacts on communities in the neighboring area. Measures taken by working units during the construction period are entering and exiting project area are permitted only through one access. Coordinate with the Port Authority, as well as notification informing all passers-by in advance. On days of road blockade, PAT officials will assist in facilitating guests at the site. Arranging for security officers to supervise and check all coming and going people at the project area at all time. Setting up various warning signboards at the site and around the project to inform all commuters in the area, as well as setting light signals, lighting at night, at barriers and detour area. Separate traffic lanes with colors painted to be noticeable. Arranging the work safety officers to register with Labor Welfare and Protection Department, Chonburi Province. The site safety officers will perform the duties such as inspecting and checking machineries and tools in the project, as well as supervising workers to adhere to safety measures. Fire extinguishers are installed to prevent and to serve as preliminary mitigation of fire incidents, both in offices and personnel residential area. It is also supplemented with a plan to train primary fire protection to the contractor personnel in order that they are knowledgeable and able to use fire extinguishers properly. Machineries and tools are checked for readiness before the start of work and regularly checked at a specified interval. All damaged tools are repaired before work starts every day. Personnel using screws, blades, and welding tools must handle work with care and wear protective gears, such as welding masks and goggles, and flammable materials must be moved out before work starts. Slings used in lifting heavy load objects or molds must be checked for loading capacity and safety before operation each time, and replace the slings when the using age is expired or when damaged. work platform and safety rails in work area must be in good condition and ready for work at all time. The area must be unobstructed by left object and must piled up in place, not be an obstacle at work. Personnel working in high places must wear safety belt. Installing a ventilation system for workers working in an airtight area. There must be a lookout man supervising the construction area at all time to prohibit anyone entering the machine working area. This is dangerous as the machine could back up without warning or run over the person. Moreover, under the crane working area, there must be some possibility that the lifted objects could fall down hitting the person. For earth excavation, sheet pile must be driven deep into the earth and strengthening the temporary earth retaining wall to prevent land collapsing. Provide the personnel welfare. The site management shall assign a safety officer to provide training for the new recruits before start working and including any personnel of any subcontractors regarding safety rules and regulations of the site. Conducting morning talk activity at 6:45 to 7:10 hours every Wednesday and Saturday before starting work to arouse the safety awareness of the personnel. Provide personnel protective gears and tools for workers during operation at all time, as well as training informing them of the usage and maintenance of personal protective gears and tools. Arrange an annual health checkup for all personnel at site so that early medical treatment regarding any specific symptom or work-related disease can be alleviated the degree of severity. Rearrange appropriate work for the severe personnel. Medicines for first aid are available by the site management. Managing of environmental impacts. Inspection and measuring of pollution in the air, noise, and wastewater are regularly conducted by the environmental unit. Water spraying trucks are arranged to reduce dust, as well as to provide personnel for cleaning the road. Preparing wheel cleaning pools for trucks entering and exiting the project area, preventing earth crumbs from the project littering the streets outside the construction area. Lorries transporting earth or stones must be fully covered with canvas, preventing any fallout or spreading dust. Providing garbage receptors and separated garbage bins for individual personnel to separate their garbage according to its classification before discarding, and coordinating with the Port Authority of Thailand to dispatch a garbage collecting truck into the site daily. Preparing camps for security personnel and safety officers, as well as clean and sanitary toilets to prevent water runoff from entering public water sources, as well as installing wastewater treatment system in the project area